Hello and welcome to Train Signal. You are watching Internet Protocols. In our previous lessons, we've spent a lot of time talking about the inner workings of Linux and how it interacts with system hardware. That discussion hasn't included networking, until now. Besides running as a standalone system, which it does quite well, Linux systems can also be part of a larger network. They can function as time servers, as we learned in our Linux system time and localization lesson, or it can serve as a database server, perhaps running the SQL Server software that we talked about in our Linux databases lesson. The point is, though, Linux boxes are easily configured to perform many functions in a networked environment. You usually only need to download the appropriate package. Networking is no simple task, though. In addition to the hardware, you must understand the concepts of protocols, ports, and addressing. Those of you coming from a Windows administration role will find many of the concepts familiar, and that's definitely a good thing. So in this lesson, we'll review basic networking and TCP/IP concepts. Then we'll talk about the different protocols. Next, we'll cover IP addressing and host names and how they're used to identify hosts on a network. And we'll wrap up with a look at ports and how programs use ports to facilitate network communications. Let's begin with networking and TCP/IP on the next slide. Before we talk about TCP/IP, let's review protocols. You probably already know that a protocol is like a set of rules and regulations, and these mandates determine how two systems communicate. Think of a protocol like a common computer language, one that each system, no matter how different, can understand. IP is the protocol used on the Internet, and combined with Transmission Control Protocol creates a network stack. And we'll talk more about that in just a moment. So we have a protocol that facilitates communications, but you also need hardware. Hardware components like network cards, or even some external devices, allow computers to communicate by facilitating data transfer. The most common type of network hardware is called Ethernet, which uses twisted pair cabling, where the pairs are twisted around each other in order to minimize interference. Ethernet is commonly referred to as a base T number, like 10 base T or 100 base T, where the number indicates the speed in megabits per second. Gigabit Ethernet at 1,000 megabits per second has become the recent standard. There are, of course, other types of network hardware. You have Token Ring, which was an IBM network type that's rarely seen today. Then you have Local Talk, which was used on early Macs, though most of those now probably use Ethernet as well. Then you have Fiber Distributed Data Interface, or FDDI, and also High Performance Parallel Interface, and others, which are high-speed type interfaces. These support even greater cable lengths than Ethernet. Wired networks aren't the only game in town. Wireless networks are almost always available today, whether it's in the home or the enterprise. Wireless networking types, or Wi-Fi, include 802.11, 802.11.b, then you have G, and even N. 802.11a and G have a maximum speed of 54 megabits per second. B is 11 megabits per second. And N, the newer standard, is up to 3 We know how the network contacts a computer, but we also need to know how to contact a program. Network ports let you send your request to a specific program. These ports are assigned to programs at startup. This table highlights the most common ports and their applications, and it stretches over the next several slides. This is information that you'll absolutely need to memorize for the Linux Plus certification exam. So we'll walk through each port by number, the transfer protocol it uses, its purpose, and the types of servers that may use this port. First we have port 20, which uses the TCP transfer protocol. Its purpose is for FTP data, and an example server is ProFTPD or VSFTPD. Port 21 is exactly the same. Then we have port 22, which uses TCP. Its purpose is for secure shell, and example servers are the OpenSSH server and Dropbear. Next we have port 23, which also uses TCP, and its purpose is Telnet. And an example server is in.telnetd. Then we have 25, which is another TCP protocol. Its purpose is SMTP, and an example server are the ones that we covered in our email and printing lesson: SendMail, Postfix, Exum, and Qmail. Continuing our review of network ports, next up is port 53, which uses both TCP and UDP transfer protocols. Its purpose is DNS, or Domain Name System, and an example server is Bind or DJB DNS. Next, port 67 uses UDP, and its purpose is Dynamic Host Configuration Protocol or DHCP. Example servers are ISC and DHCP. The next one you should recognize, port 80, which uses TCP, and its purpose is Hypertext Transfer Protocol, or as we all know it, HTTP. Example servers are Apache, Roxen, and THTTPD. The next one we should also recognize, which is 110, and uses TCP, and port 110 uses POP3. Example servers are Dovecot, QPopper, and POP-A3D. Our port review continues with 111, which uses TCP and UDP. Its purpose is Port Mapper. Example servers are NFS, NIS, and RPC services. Next we have 113, which also uses TCP. Its purpose is auth/ident, IDENT, and the example server is identd. Next up we have port 119, which uses the TCP transfer protocol. Its purpose is Network News Transfer Protocol, or NTTP, and example servers are Internet News, or INN, and you've got Diablo and LeafNode. Port 139 uses TCP as well, and its purpose is NetBIOS, which is a Windows sharing program. An example server is Samba. Next is another recognizable one, which is 143, and uses TCP, and its purpose is IMAP. Example servers are Dovecot, Cyrus IMAP, and UW IMAP. Our network port review continues with 161, which uses the UDP protocol, and its purpose is SNMP, or Simple Network Management Protocol, and example server is NetSNMP. Next we have port 177, which also uses UDP. Its purpose is XDMCP. Example servers are the display managers that we learned about in our display manager lesson, and they're XDM, KDM, and GDM. Next there's port 389, which uses TCP. Its purpose is LDAP, and an example server is OpenLDAP. The next port, 443, uses TCP as well, and its purpose is HTTP over SSL, or HTTPS. Example servers are Apache and Roxen. The next port is 445, which also uses TCP, and its purpose is Microsoft Directory Services, and an example server is again Samba. 465 uses TCP, and its purpose is SMTP over SSL, or URL Rendezvous Directory. Example servers again are SendMail, Postfix, Exum, Qmail, or network routers. The list of ports rounds out with 631, which uses the TCP transfer protocol. Its purpose is Internet Printing Protocol, and an example server is CUPS that we learned about in our email and printing lesson. Next we have 993, which also uses TCP, and its purpose is IMAP over SSL. Example servers are Dovecot, Cyrus IMAP, and UW IMAP. Port 995 uses TCP/IP, and its purpose is POP3 over SSL, and it has the same example servers as 993. Next we have 5900 Plus, which uses TCP, and its purpose is Remote Frame Buffer. Example servers are VNC, and also OpenVNC and TightVNC. And finally we have ports in the range of 6000 to 6007, which use TCP, and their purpose is the X Windows system, and the example servers are x.org-x11 and xfree86, the servers that we learned about in the X11 installation and configuration lesson. It should be noted that ports below 1024 are called privileged ports, and access to these ports is restricted to root. This was a built-in security measure intended to ensure these services were trusted. The unprivileged ports are those greater than 1024, and they're open to all users. Most of the time you won't have to change these ports, but if you do, you'd edit the etc services file, which maps port numbers to names. Let's go back to the terminal and take a quick look at this file. I'm going to go ahead and clear the window. Then I'm going to type in cat space etc services and hit enter. And we have a pretty long list. In the first column here, you have a server name, then you have the port number and the transport protocol, and then you typically have some comments over here that describe things. Let's scroll up to take a look at this list a little closer. This goes all the way to the top. And again, if you wanted to edit this file and add in some new port mappings, you can open it up in your Vi editor. Okay, let's head back to the presentation. And that concludes our lesson on Internet protocols. Let's review what we've learned on the next slide. In this lesson, we covered Linux networking and TCP/IP. On the hardware end, we learned that Ethernet is the most common network interface and that TCP/IP is the protocol you'll most likely use. We then reviewed the different types of TCP/IP protocols. Next, we talked about IP addresses and how they're used in conjunction with host names to identify computers on a network. We wrapped up with a look at network ports and how they are assigned to specific programs. Thanks for watching, and I'll see you in the next lesson.